So, my dear people, what do we have here? We are given that the efficiency of a fan depends on the density, the dynamic viscosity, the angular velocity, and the diameter of the rotor. Assume constant discharge. Anything that is constant in dimensional analysis, we can just eliminate it. Using Buckingham's pi theorem, find an expression for the efficiency. That is really easy. Yeah, let me take you step by step in doing this particular problem. So the efficiency, we know eta is a function of, what do we have? Density rho, dynamic viscosity mu, angular velocity is omega, and the diameter d. These are the things that we have. So we can also write this as function of efficiency rho mu omega and d equals 0. The first thing, if you remember in Buckingham's pi theorem, is to find the number of variables and the number of fundamental dimensions. How many number of variables are there? Number of variables n equals 1 2 3 4 5 5. Yeah, so let us find the number of fundamental dimensions. Yeah, that is m. How to find it? We have to write all the dimensions of these things, of the variable. So rho, what is the dimension of it? M L power minus 3. And then we have mu. What is the dimension for mu? It is m L power minus 1 T power minus 1. And then we have efficiency. Efficiency has no unit. Yeah, efficiency has no unit. And then we have omega. Omega is T power minus 1. And then we have diameter. Diameter is just length. So all that we have to do is to count how many number of dimensions, fundamental dimensions are there. M, L, 2, T, 3. Are there any other ones? No. M, L, T, M, L, T. These are the three fundamental dimensions. So number of fundamental dimensions is 3. So the number of pi terms equals n minus m, which is 5 minus 3, 2. So we are going to have 2 pi terms in this particular thing. So I can write this as the entire expression as f of pi 1 comma pi 2 equals 0. Yeah. So let us write each of the pi terms individually. In order to do that, we have to find the repeating and non-repeating variables. So what are the variables we have? 1 2 3 4 5, efficiency, rho, etc. We cannot choose efficiency because efficiency is the dependent variable. So, well, you know what, I'm going to choose d, diameter, omega, and rho as the what is it, the repeating variable. So the other two, efficiency and mu, are going to be the non-repeating variables. Yeah, I have given you an explanation of how to choose repeating and non-repeating variables. Just refer to that. So I'm going to write pi 1 equals the repeating variable I'm choosing as, let me write it, let me just mark it in different color. Repeating variable 1 2 and 3. These three are going to be the repeating variable. So I'm going to write it as pi 1 is d power a times omega power b times rho power c times one of the non-repeating variables. So I'm choosing it as efficiency. Yeah. What about pi 2? Pi 2 is, I'm writing all the repeating variables as they are: d power a times omega power b times rho power c times the other non-repeating variable mu. That's it. Yeah. So I'm going to call this as equation 2 and equation 3. So now if you remember, all that we have to do is, for each of the pi term, for pi 1 and pi 2, we have to find these values a, b and c. That is all that we have to do. Yeah. And if we can find it, we'll have two equations and we can substitute them in equation 1. Yeah. So let us find the values for pi 1 and pi 2. Yeah. Pi 1, if you think of it, is a dimensionless term. So m power 0, L power 0, T power 0 equals, what is the, well, I'll just write it all over here: d power a times omega power b times rho power c times efficiency. Yeah. So I'm going to write all of them in the dimensional form. What is the dimension for d? We have it as L. L power a times omega is t power minus 1, t power minus 1 power b times rho is ml power minus 3 times c times, well, if you think of it, efficiency has no dimension. So how can I write it? I can just write it as m power 0, L power 0, T power 0. Yeah. It doesn't really make any sense if we have it or if we do not have it. Yeah. Let me expand on this equation. M L T power 0 equals L power a times T power minus b times m power c times L power minus 3c times m power 0 L power 0 times T power 0. Yeah. Now let us equate all the powers of m. So m is 0 on the left hand side equals, what are the terms in the right hand side? There are only two m terms, c plus 0. So c equals 0. Fantastic. Let us look at the t. For t, the power is 0. 0 equals, how many t terms are there? 1 and 2. So minus b plus 0, which means b is also equal to 0. Let us look at the L terms. The power of L is 0 equals, how many L terms are there? 1, 2, 3. 3 L terms are there. So L power a is nothing but a minus 3c plus 0 here. 0. Yeah. Okay, now we already know the value for b and c. C is 0. Yeah. So this term will also become 0, which means a is also equal to 0. So we have found the value of a, b and c. So substitute in pi 1. If we substitute in pi 1, which is nothing but equation 2, if you think of it. Yeah. Pi 1 is equation 2 here. So if I substitute it, pi 1 equals d power 0 times omega power 0 times rho power 0 times efficiency, which means pi 1 equals, this is 1 1 1 efficiency. So pi 1 equals efficiency. This is equation 4. Yeah. So I have found pi 1. So all that we have to do now is find the values for a, b and c in pi 2. So let us write all the variables in dimension form. Pi 2 is a dimensionless term. So m power 0, L power 0, T power 0 equals, Again, look at this. D, omega and rho are all repeating variables, so they are all going to have the same dimensions as here. Yeah, so D is L power A times omega is T power minus 1 times B times density is, so M L power minus 3 power C times the dimension for mu. Mu is M L power minus 1 T power minus 1. So if I expand on this, M power 0 L power 0 T power 0 equals L power A times T power minus B times M power C times L power minus 3C times M power 1, because that is what it means, times L power minus 1 times T power minus 1. Now let us equate the powers. Yeah, so for M, what are the powers? The power is 0 equals, how many M terms are there? 1, 2. 0 equals C plus 1, so which means C equals minus 1. In terms of T, what is the power? Is 0 equals, how many T terms are there? 1 and 2 T terms, so the power is minus B minus 1. Yeah, so B equals, minus B goes to the other side and becomes plus B, so B equals negative 1. Fantastic. Now let us look at L. What is the power? 0 equals, how many L terms are there? 1, 2, 3 L terms are there, so the power are A minus 3C minus 1. So since we already know the value for C, which is negative 1, no, so minus 3 minus 1 is plus 3, plus 3 minus 1 is plus 2. When it goes to the other side, it becomes minus 2. Well, so A equals negative 2. People, you can do it yourself. Yeah, so now I have the value for A, B and C, so all that I have to do is substitute in the pi 2 equation. So pi 2 equals D power, yeah, D power A, we have found it to be negative 2 times omega, and the power is B we have found out to be negative 1 times rho to be negative 1 times mu. This is what we have found out. So this one, my dear people, we can write it as mu divided by d power minus 2. When it goes to the goes below, it becomes omega and rho, d square omega rho. This is what it becomes. Yeah, pi 2. So now we have found both pi 1 and pi 2. Pi 1 comma pi 2 in equation 1, because that is what we know, that is what we want. Do you see? Yeah, equation 1 is f of pi 1 comma pi 2 is 0, so I can write it as f of pi 1 is efficiency comma pi 2 is mu by d square omega rho equals 0. And now if you think of it, what is the question asking us? So find an expression for the efficiency. So we have to have efficiency outside. So efficiency is equal to a function. We do not know what function it is. Yeah, a function of, yeah, mu divided by d square omega bravo.